Okay, today what I wanted to do is work on another integral. We have one here from MIT 2012, problem 23. We have the integral from 0 to 2 of x to the fifth times the square root of 1 plus x cubed dx. Okay, really the whole issue we have here is just dealing with this radical with 1 plus x cubed. We need to simplify that, and we can do that with a u substitution. It's going to make our x to the fifth term more complicated, but I think it's going to be worth it. So let's see how this looks. I'm going to make my u equal to, we could do the whole radical, but I'm going to do just the inner part, 1 plus x cubed. And then we'll take our derivative and we'll have du equals, derivative of 1 is 0, derivative of x cubed is going to be 3x squared dx. And what I think I'll do is just rewrite the integral in a way where we can use this. Because we don't have an x squared here, but we can break up this x to the fifth as x cubed times x squared. So let's rewrite this, and we'll have, so I'm just going to force my 3x squared dx here. And then by doing this, we can create over here, we'll write it as 1/3 x cubed. Just noticing 1/3 x cubed times 3x squared gets us back to our x to the fifth. And then we almost have everything we need. We just need something for x cubed. So we can just subtract a 1 here and solve for x cubed. So we're going to have x cubed is going to be equal to u minus 1. Now I think we're ready for that substitution. So first we'll plug in a 2 here. 2 cubed is 8 plus 1, we'll have a 9. And then plugging a 0 in, we're just going to have a 1. And I'm going to take this 1/3 up front right here. Our x cubed we just found, so that's going to be u minus 1. For the radical term, this is just going to be square root of u. I'm going to write this as u to the 1/2. And this piece here is just going to be our du. Next what I'm going to do, I'm just going to distribute this in here so we can get it and set it up for the power rule. So we'll have 1/3. Then multiplying this inside, we're going to have u to the 3/2. Then the second term is going to be just minus u to the 1/2 du. Now we're ready for the power rule. We'll keep our 1/3 up front. U to the 3/2 is going to be, adding 1 is going to be u to the 5/2 reciprocal. We'll have 2/5 minus here, u to the 1/2, add a 1, we'll have u to the 3/2 with the 2/3 up front. And then one more thing before we evaluate this, I want to try to make it easier. This is kind of where I personally make the most silly mistakes, is when I just evaluate something like this. So what I'm going to do is I'm going to factor out of the inside here, I'm going to factor out 2 over 15. Because I'm taking the 2 in common, and then we don't have a common term in the denominator, but if I create it like 15, it's going to clean this up a little bit. So we'll have 3u to the 5/2. Just noticing 3 times 2 over 15 is 2/5. And then here we'll have a minus 5 u to the 3/2. Noticing that minus 5 times 2 to the 15th is our minus 2/3 here. This right here, this actually evaluates to 2 over 45, just multiplying through by 15. So, okay, so now we'll just evaluate this thing. The nice thing about having the 1/2 here is when we plug in a 9, so 9 to the 5/2, we can get the square root first and have 3 to the 5th, 3 to the 5. Then we'll have a minus 5. Again, square root of 9 is 3, so we'll have a 3 cubed here. Then we'll evaluate our 1 term. So that's going to be just 3 minus 5 in here. Then from here, this is actually just 3 to the 6. 3 to the 6 is 729. Then here we have 27 times 5. That's 135. Here we'll have a minus 2, but we have a minus 2. So then just doing this arithmetic, 729 minus 135 plus 2 is going to be 596. So then our final solution, we're going to have 2 times 596, which is 1192 over 45. I think a problem like this, the hardest part is actually just evaluating the arithmetic at the end, not making a mistake. So anyway, we'll stop it there. MIT 2012. Thanks for watching. Please like and subscribe. Have a great day.